Solid Edge is the absolute best tool for design repurposing using synchronous technology. Synchronous technology enables us to easily take an existing design and reimagine and repurpose it by precisely morphing and changing it for better aesthetics, for improved performance, or for a completely different purpose. This is a great time saver over starting from a blank slate. In this example, let's use synchronous technology to completely redesign this jack stand from the square-based design on the left to the pyramid-based tubular design on the right. Notice that we are in an assembly, and yet we can select faces of parts and modify them directly without actually diving into the part model itself. This saves us time by not requiring us to go in and out of the part in assembly environments to make the changes. By disabling the offset design intent, we can remove the bottom plate by simply dragging the bottom face up to the point where it disappears. We can use this same technique to remove the recessed area of the angled ribs. The Selection Manager tool enables us to interrogate the model automatically to detect and find all the rounded corners that contain the same radius, and in this case we'll use the selection to remove these rounds. Synchronous technology maintains symmetry in the model by recognizing another design intent relationship as we drag the face to the corner of the rectangular section. Note that all the sides are also updated to reflect the same change due to design intent and patterning. Just like the first edit we made, we'll select the side face and rotate it by strategically relocating the steering wheel to the top vertex to rotate the faces to converge to form the pyramid shape. Changes can also be made by selecting geometry, like rounds, and changing their values directly. You can even add equations and let Solid Edge do the math to get the right dimension. By adding full rounds to the corners, we can easily change this design from square to round. Finally, let's change the overall height of the base by adding one more PMI dimension. Notice how the lock dimension maintains the hole relative to the end of the post. Now that we have the shape we want, let's add a few more features to complete the new design. As we add some rounds to the base, note that all of the changes we just made to this model to transform it to the new design could have just as easily been applied to an imported model from another CAD system. The intersecting sketch elements become regions that can be used to either extrude or, in this case, cut away part of the base. To complete the design of the base, we'll simply create a pattern of the cutouts to the other three angled faces of the base. This is an associative pattern, meaning if later we change the cutout, the change will be reflected on all four faces. As we return to the assembly, it's easy to see that our square post no longer fits in the round base. This is not a problem with synchronous technology. Once again, we can modify the corner rounds to consume the flat faces and make a round post. Finally, let's use synchronous technology one more time to change multiple parts at the same time from the assembly. So the next time you want to create a new design, look around and see if you have an existing model that is similar, and using Solid Edge with synchronous technology, repurpose it for your new idea.